Once again, you welcome back to our online lesson, and we are continuing with discussion on graph of functions. So in our previous lesson, I left some two questions for you to sketch the graph of those two questions. There was one which was a combination of a quadratic and then a linear function, and there was another which was only a quadratic graph. So without wasting my time, let me share what I expected you to get for me. So this is one of the questions. This one of the questions on a graph, on the same graph sheet, draw the graphs f of x, which is equal to 6 minus x minus x squared, and g of x equal to s plus 3 on the same axis, and then with scales 2 centimeters to 1 unit on both x-axis, or on the x-axis, and 2 centimeters to 5 units on the y-axis. So ideally, I use the software to draw the graph. The name of the software is GeoGebra. Maybe as the lesson goes on, I'll be using it, so you definitely observe whatever is going on. So we're given the domain, and the domain was from -4 less or equal to x and less or equal to 3. Yeah, that was the domain we're supposed to use. But with the software that I'm using, it draws the graph neglecting the limit of the domain. You know, the domain gives you some interval for which you have to work with. But with whatever software I used, it gives it from infinity to infinity, positive infinity to negative infinity. That's why you can see that on the graph here, it doesn't limit you. But if you drew it, then it means that you are going to start it from -4, meaning your graph will have from -4, which will be somewhere here. I think the yellow marker will do. So from somewhere here to 3. 3 will be somewhere also here. Yeah, because when you trace it, 3 is here and -4 is there. So that's where your graph will actually start and then end. So the curve is a quadratic graph, and then the line is a linear graph. So that is what I expected you to draw. As in answering the questions, I said no, we'll be doing that today. So that's the first one that I asked you to do. Then the second graph was this. That one too included a quadratic and a linear graph. Now you can see that there's a difference between the first one, which is this, and then the second one, which is that there's a huge difference. Whereas this one passes through the center, the second one doesn't pass through the center. So you can see that there's a huge difference. Okay, so the second graph were to plot 5x minus x squared for f of x, and then g of x is 8 minus x on the same axis, given the interval. Then after which you use a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 5 units on the y-axis. So I just wanted you to draw it. Per the questions, as I said, we'll be doing it today. Please, are you all okay with the graphs that I've shown?
Yes, sir.
Okay. So if we are all okay, I'm pausing. If you have any question pertaining to drawing the graph, please let me know. If I forgot to say this in our previous lesson, whenever you finish drawing the graph, I will plead with you to put the name of the graph there. And the name of the graph is a function given to you. So for instance, the curve is f of x. So you write just by the side. So f of x is equal to 5x minus x squared. It doesn't matter if it interferes with the graph, but you should write it boldly for the examiner to know what type of graph it is. Then the linear, per the software, it just wrote G and then F because it understands what it's doing. So for you, you must write the name of the function attached to the graph. So please take note of that. Okay, so then if we have no question to ask pertaining to drawing the graph, then let us just go through some of the questions they may ask you after you have drawn your graph. The questions that they may ask includes coordinates of the point of intersection of the two graphs or functions. Then the coordinate of the turning point, which is very key. We'll be talking about it today. The maximum or the minimum value of the function, the zeros of the function, the range of f for the given domain, then the equation of the axis of symmetry, and so on and so forth. Actually, basically, we'll be doing most of them today, and the rest will be considered in our next lesson. Good. So in today's lesson, we are actually going to look at what we call the features. The features of quadratic graphs or quadratic functions, into bracket graphs, because we are dealing with the graph aspect. These are, I'm going to take them one after the other. I can't finish everything today. If I try to finish everything today, you never understand anything. So please bear with me. I have to take it slowly and smoothly. So features of quadratic graphs, it includes number one, what we call the line of symmetry. In other words, you can say the equation of the line of symmetry. Now, I will explain this into details very soon. Number two, from the same quadratic graph, they can ask you to determine what we call the min or the max values or point. They can ask you to determine the minimum or the maximum values or point. Then other features includes what we call the range of values of x as the function increases or decreases. Then they can also ask you the range of values of x for which the function is positive or negative. Now, mathematically, when it is positive, we can write it as y is greater than 0. And when it is negative, we can write it as y is less than 0. So if you don't see the word positive or negative coming, they can use this notation, and it still means positive and then negative. Then they can also ask you, number 5, the roots of the quadratic equation or quadratic function. Let me make it function. Now, in all cases, they will ask you to use, let me stress on it. Let me use so use your graph to determine so all these things that I've written here, they'll always ask you to use your graph to determine. So even if you may have other means of getting the answer, they don't want it. They want you specifically to use the graph to get the answers. Finding the line of symmetry, finding the minimum or maximum values or points, then the range of values of s for which the function is increasing or decreasing, the range of values of s for which the function is positive or negative, the roots of the quadratic equation. Then number 6, they can ask us to solve or find a solution or solution set for quadratic equation. Sometimes even it goes ahead to bring on board simultaneous equations. For instance, the previous graph that I gave you, per this question, they can ask you solve for the simultaneous equation here using your graph. Yeah. My people, are we all ready to learn all these features of quadratic functions? Are we all ready, please? Okay. So since we are ready, then let's take them one after the other. One after the other. The first that we want to look at is actually known as finding the equation of the line of symmetry, of determining the line of symmetry. Per the graph that we have here, per the quadratic graph that we have here, we are not interested in the linear one. We are only interested in the quadratic graph. So let our mind be on the quadratic graph. When we talk about the line of symmetry, it is simply a line that partitions the graph into two equal halves. It is a vertical line drawn. So the line of symmetry is a vertical line drawn to divide the quadratic curve into two equal halves. So that is what the line of symmetry is all about. It's a vertical line drawn to divide or partition the curve into two equal halves. So looking at the green graph that we have, or the quadratic curve that we have here, where do you think we can introduce a vertical line so that it will divide it into two equal halves? Now, just look at it carefully. Let's estimate that I draw a line over here. I draw another line here. I think I'll use a different color for that line. Let me use a green color for that line. I draw another line here. This time around, I'll use blue. Another line here. Now, I've drawn 3 vertical lines. The green, the red, and then the blue vertical lines. Which of them do you think has partitioned this curve into two equal halves? Which of them, please?
Please, the red.
Is the red one. Because now look at something here. When you pick the green one, you realize that if you pick the green one, this part of the graph, will be smaller than the other part, the other remaining section. If you also pick the blue one, this part of the graph will be smaller than the other section. But with the brown or with the red line, it actually partitions the curve into two equal halves. So the position of the red line is actually known as the line of symmetry. And because we introduce the line of symmetry, it automatically cuts the x-axis, or it passes through the x-axis. Therefore, whenever you are stating the line of symmetry is always stated in terms of x equal to a number. Because the vertical line that you always draw partitions the curve into two equal halves, it always passes through the x-axis. And the number on which it passes through is what you state. So immediately you are able to write it as x equal to a number. Automatically you've established what we call the equation of the line of symmetry. So per my position of the red line, what do you think is the line of symmetry for my quadratic curve here? What do you think it is?
So it looks like negative 0.5.
Negative what?
0.5.
Negative 0.5. Okay, so you can estimate it as negative 0.5. Negative 0.5. So we will say then x is equal to negative 0.5. And as I always say, because you are using the graph, we always give plus or minus error. And your answer must find itself within the plus or minus error. Please, are we all clear about equation of the line of symmetry? So that I move on to something else.
Yes, please.
Good. If that is clear, the next thing we need to talk about is what we call the maximum or minimum values and points. We have to begin with the values before we come to the points. We have to begin with the values before we come to the point. So then again, I'll have to go for my quadratic graphs. We found out that we have two major quadratic graphs, and the shape of any quadratic curve is parabola. So we learned that the curve is either minimum, which is it's like a calabash holding water. That is minimum. And then it equally can be maximum, which is like a calabash turned upside down, pouring water. So that is max. Good. In order to obtain the minimum or maximum value, you must first establish what we call the line of symmetry. That is why we first found the line of symmetry. The max or minimum values talks about what we call the y component or the y coordinate. So the max or main value is actually linked up with the y values. So when you are able to establish your line of symmetry, which is a line drawn to partition the graph into two equal halves, let's assume that I've established my line of symmetry here, or I've established my line of symmetry here. After getting the intersection of the line of symmetry and the curve that you've drawn, so I have my intersection here. This is where my intersection is found. It's here. and this is where my intersection is found. It's here. All that you need to do is to trace it towards the y-axis and read the value. So trace to read y coordinate. So then again, if it is for this one, you either trace it towards the y-axis if it's on the left, or trace it towards the y-axis if it's on the right. So it can be the other way around, any of them. But immediately you are able to connect it, that gives you the value. Please, is it clear?
Yes, sir.
There is no way in a given quadratic curve you will have both minimum and maximum values. No, you will either have only one of them. And we learned early on that you can even use the function given to you to determine whether the graph you are going to draw is going to be maximum or is going to be minimum. And we found out that when the coefficient of x squared, which is a, is greater than 0, then we expect it to be minimum. But when it is less than 0, we expect it to be maximum. So when a is less than 0, we expect it to be maximum. But when a is greater than 0, we expect it to be minimum. And the final of it, so remember the white line is my line of symmetry. This is my line of symmetry. The white line is a line of symmetry. So that is about the maximum or minimum values. Now about the points. Points is known as, or another way you can classify points is actually coordinates. So points are actually coordinates, and coordinates are always x, y. Therefore, if they want you to find the maximum point, then it means after getting your line of symmetry and then the maximum value, you put the two numbers together in a bracket, then that gives you the maximum point. If it is the minimum, after getting your line of symmetry, trace the intersection of the line of symmetry and the graph towards the y-axis. Then you combine the two values as a pair, and automatically it gives you the minimum value. Please, is it clear?
Yes, please.
All right. Any question before I move forward? Because we will have to take one example and then we'll actually get going. And the example will be whatever we've already drawn. So we are not going to draw it all over again. Okay. If there is no question, then we are proceeding. Therefore, this is one graph we've actually drawn. And if I may ask, pair this graph among maximum and minimum, where will you classify this curve? Is it going to be maximum or minimum?
So maximum.
So this is a maximum curve or a maximum function. So this is maximum. And since it's a maximum function, then it means that questions like line of symmetry can be asked. Questions like maximum value can be asked. And questions like maximum point can be asked per this curve alone. So let us determine, we've already established the line of symmetry, and we saw that the line of symmetry is x equal to 0.5. I remember one person saying x equal to 0.5. But you don't just say that x equal to 0.5, but you give us an evidence that you are using the graph to read those values. So the evidence must be in drawing the line of symmetry. You need to draw it. If you don't draw it and you just quote the answer, you'll be marked wrong. Remember, I told you that they will always say, use your graph, determine, then the question follows up. So every evidence that you have should be taken from the graph. Now we've seen the line of symmetry as 0.5. The next is to determine the maximum point and maximum value. So we are looking for max value. The maximum value is always stated in terms of y. So as I said, when you get your line of symmetry, the intersection of the line of symmetry and the curve drawn must be traced towards the y-axis to read the value. So let us trace it. So tracing it, actually it falls here. This is where it finds itself. What do you think will be the maximum value? Y equal to what number, please?
6.2.
So we can establish it as 6.2. 6.2. As I said, we have plus or minus error. We have plus or minus error. So you are okay. Good. So this is how you use your graph to determine the line of symmetry and then the maximum value. Now, if the question demanded for maximum point, then as I said, you put the two components together and the answer will be 0.5, 6.2. Please, are we all clear?
Yes, sir.
Okay. Now, I'm going to show you another way you can cross-check whether your answers are right or close to being right. So I'll need your attention so much. Now, so even whatever I'm going to show you now in exams, you must not do it on the answer booklet. You can use it to cross-check whether you are getting everything right or not. So not for you to use it, but you can use it to find out whether whatever you've done is right or not. Can I proceed? Okay. Now, another means by which you can use to determine the line of symmetry is by calculation. By calculation. So, line of symmetry by calculation. And you write it as x. You know, always the function is f of x equal to ax squared plus bx plus c. That is the general quadratic function. Now, from the quadratic function, if you want to determine the line of symmetry, all that you need to do is to use a coefficient. So, equation of line of symmetry is given as x equal to minus b over 2a. X is equal to minus b over 2a. I hope each and everyone will remember it in case you want to verify whether your answer that you've given is right or not. So it is minus b over 2a. Are we all okay? So now, per our question, the graph was 6 minus x minus s squared. 6 minus x minus s squared. So f of x. So example, f of x 6 minus x minus s squared. Now, before you can select your coefficient, the best way to go about it is to rewrite the function to conform with the actual quadratic function. So when we rearrange it, it will be f of x equal to minus x squared minus x plus 6. Then you compare to come up with your a, your b, and then your c. What is our a value in the function here?
-1.
So we have -1. And then b is also -1. But our c is 6. And remember we said x is equal to minus b over 2a. Because we are not doing elective math, I wouldn't like to explain how this formula was established. So using x equal to minus b, our b itself is already negated, so it is going to be minus into bracket -1 all over 2 times a, which is -1. Going further, we'll have it as s equal to, here will become +1 over -2. And +1 over -2 is the same as x equal to minus 0.5. Please, are we all okay?
Yes, please.
So it is true that we had the answer perfect. I didn't bring the negative sign, sorry. It's minus 0.5. Good. Now, after using calculation means to check whether you've had your answer right, how about we determining the maximum or minimum value? Per our question, it is maximum value. So if I want to use calculation means to get the maximum value, so maximum value, all that you need to do is substitute the equation of line of symmetry into the function f of x. So if you want to find out whether our maximum value is right, what was the function? The function was f of x equal to 6 minus x minus s squared. So we substitute for x. So finding f of -half, it means you are going to have it as 6 minus into bracket -half, close bracket, then minus into bracket -half all squared. So you just substitute your s value for the line of symmetry into the original function. Please help me with the calculation. What are you getting? I know you get something like 6 plus half, then minus 1 on 4. So please do the math for me, add and subtract, and tell me the answer, please.
So 6.25.
6, please can you repeat it again?
6.25.
So we are having 6.25. 6.25. And what did we actually write down for using the graph to get the answer? We said that it was 6.2. So it means we are still right. We fall within the interval. Please, are we all clear? Any question? Any question before I move on, please? Any question before I move on? Today, we are actually looking at the features of a quadratic curve. And what are they? It includes the line of symmetry, it includes the maximum or minimum values and points, and there are more ahead. All right. If it is clear, this is a summary of whatever I've just said today. This is a summary. You can screenshot it before I move on, please. We have some few minutes for the lesson to end, so just take a screenshot so I can move forward. Now, another name that you can actually be seeing includes greatest value or the least value, the greatest value or the least value, and so on and so forth. Now, greatest value is the highest value, and then the least value is the smallest. So bear in mind, they can ask you questions on that. Okay, so if there is no question, now I would like you to try this. But for the sake of time, I'm going to do that with you. Just copy the function. Just copy the function, please. 6 plus 2x minus x squared. So that will be ending the lesson. So I'm going to draw this graph, after which we answer the questions. The questions are find in the given interval the equation of axis of symmetry, which is the same as the mirror line or the line of symmetry. Then after which determine the greatest value of this, meaning the highest peak it can reach. Then the coordinates of the greatest points of the curve. All right, so I'm going to switch from this screen to another screen, so please bear with me in seconds of time. So this is what we call the GeoGebra. The GeoGebra is a software, the GeoGebra, and therefore I'm going to key in the function. Please, what's the function? Help me with it. It was f of x is equal to what?
6 plus 2x minus x squared.
6 plus 2x minus x squared. Was that it?
Yes, please.
X squared. So the graph has automatically drawn. What type of graph is it? Is it minimum or maximum?
Maximum.
Good. Hence, what were the questions the graph was asked on? Yes, what are some of the questions? We should find the what?
Equation of the axis of symmetry.
Therefore, we need to introduce our vertical line to partition this graph into two equal halves. What do you think the vertical line will pass through?
1.
It will pass through 1. Very good. So the equation of the axis of symmetry is x is equal to 1. Finish. Then again, we were asked to find the greatest value. The greatest value. Yes, what do you think it is? Which is the y value. So after getting your x component, how do we get the y component? Introduce short dashes towards the y-axis. And what number does it fall on, please?
7.
It falls on 7. It falls on 7. So it means the greatest value is 7. The equation of the line of symmetry is x equal to 1. And what is the final question? We should determine the greatest point, right? You put the two values together in a coordinate form. So what is the answer?
7 and 1.
It is, can you repeat it again?
7 1.
Are you sure it is 7 1?
It's a 1 7.
It is 1 comma 7. 1 comma 7. All right. So that is it. That is it. That is the question that we're supposed to answer. That's the question that we're supposed to actually answer. Now we can equally, as I said, if we want to find out whether our answer is right or not, I'm switching the screen, so please take note. I'm switching. So I'm back to my page. Can you see the writing screen now?
Yes, sir.
Okay. So we just want to confirm whether the answer that we had, we said that for the equation of the axis of symmetry, we have it as x equal to 1, and then the greatest value was y equal to 7, and the greatest point of the curve is 1 comma 7. But I want to confirm using calculation means. So finding the equation of line of symmetry, we said it will be given as x equal to minus b over 2a. Per the function, what is b? B is what number there? Per the function here. B is what number, please? That is positive 2. And then a is what number? Negative 1. Therefore, s equal to minus of b, which is minus of 2, divided by 2 times a. So we have 2 times negative 1. Now, at the end of the day, you are having negative 2 over negative 2. Finally, 1. And it is true that our equation of the line of symmetry was 1. Now, to get a corresponding y value, as I said, the max value, then you substitute the answer you've had into the original function. So we had f of, okay, actually it was y, so y is equal to 6 plus 2 times 1 minus 1 all squared, and y will be equal to 6 plus 2 minus 1. 6 plus 2 is 8 minus 1, y will be equal to 7. Is it clear?
Yes, please.
All right. I'm so grateful that you've been able to follow this lesson. This is just the beginning. This is just the beginning of the features of a quadratic equation or function. So I'm going to send you some questions, more questions for you to try your hands on. Please, when you are done, inbox me with a solution so that I can give you a feedback. Thanks once again for joining the lesson, and it's a great privilege coming your way. Thanks also for watching my YouTube videos. The support is so great, and I will entreat you to keep on sharing, liking my videos. Have the best of the day. Bye bye.